Now, this is the first of two videos that I'm going to be doing on the periodic table. In this first video, we'll look at some of the basic information found in each of the boxes, how to use that information to find the number of protons, neutrons, and electrons in a neutral atom. First, to the boxes. There are 4 pieces of information in each box of the periodic table. This is directly off the periodic table that you'll be given for your end of course exam. In each box, in the top left corner, you're going to find the atomic number, always a whole number. This is beryllium's box, its atomic number is 4. Under that, you'll find the symbol for the element. Now, a few things I mentioned about symbols. First, the first letter is the only one that's ever capitalized. In a 2-letter symbol, you only capitalize the first letter. This helps make sure we don't confuse it with a compound. Make sure when you write your symbols, you only capitalize the first letter. The second thing that I mentioned about symbols is some don't match the names. This one is beryllium. It starts with a BE. The symbol is BE. That's the way it works for many of the elements on the periodic table. However, some don't match. In some cases, the symbols are based on Latin names. When that is the case, the symbol will not match the name. In many cases, it's not even close to the name. I mention this because when students are looking for elements on the periodic table, the easiest way to look for it is to scan through the symbols. If you scan through the symbols and you don't find the element that you're looking for, don't give up. Go back and scan through the names until you find the correct element. Be careful, there are some elements that have similar names, similar symbols, like manganese and magnesium. Students will mix those two up all the time. When you're looking at an element, always check that symbol, check that name, make sure that you have the right one. The name does come right underneath the symbol. And under that, the last piece of information in each box is the atomic mass. The atomic mass will always be larger than the atomic number, with the exception of hydrogen. Everything else in the periodic table, atomic mass will be the greater number, and atomic mass will have decimal values attached to it for most of your elements. Each of these pieces of information give us some kind of detail about the structure of an atom. Atomic number, the one that's in the top left corner, tells us the number of protons in our atom. So we can look at this box for beryllium and without doing any work know that the atom of beryllium has 4 protons. The atomic mass, the other number that's in the box, tells us the number of particles in the nucleus, the total number of particles in the nucleus. Recall that when we learned atomic structure, the nucleus contains the protons and the neutrons. So what this number tells us is the total number of protons and neutrons. So again, looking at beryllium's box, without thinking about it too much, we can say beryllium has 9 total particles in its nucleus. Now this is for the average atom. This atomic mass, if you look at the periodic table, actually says average atomic mass. So this is what the average atom would have. Notice how I rounded to a whole number. This says 9.01. I do not say there are 9.01 particles in the nucleus. You cannot have a fraction of a proton. You cannot have a fraction of a neutron. So I round that to a whole number, in this case 9, when I talk about the total number of particles. In summary, for those who are math-oriented that like to see things in equations, the atomic number, the number in the upper left-hand corner, tells us the number of protons. The atomic mass, the number on the bottom, tells us the total number of particles in the nucleus, or we can say the number of protons plus the number of neutrons, the total number of particles in the nucleus. If we want to know how many neutrons we have, we've got to do a little bit of math. Again, protons easy, it's right there. We have 4 of them. Total number of particles in the nucleus, real easy. It's right there, there are 9 of them. If we want to do the number of neutrons, we have to do a little math with these 2 numbers. It's pretty simple math. To find the number of neutrons, we'll take the atomic mass minus the atomic number. Always say it that way. I have students tell me you take the atomic number and you subtract it from the mass. And the problem with that is when they go to write it down on paper, they'll write it down backwards. They're saying it backwards, they write it down backwards. Learn it this way. Neutrons are the atomic mass minus the atomic number. That way when you write it down on paper, you always write it down in the right order. We take the mass, again rounding it to a whole number because you can't have a fraction of a neutron. So 9 minus the atomic number, 4, tells us that the average atom of beryllium has 5 neutrons. Again, simple math as long as you put your numbers down in the right order. That atomic number can also be used to tell us the number of electrons in a neutral atom. Key is neutral atom. In a neutral atom, the number of protons and electrons have to be the same. The number of positive charges and the number of negative charges have to be the same so that they will cancel out. We know beryllium has 4 protons because that's what the atomic number tells us. So if the atom is neutral, it must also have 4 electrons. 4 positive charges, 4 negative charges, those will cancel each other out. And the net or overall charge for beryllium will be 0. We'll do a couple of examples before I close. This is the box for scandium. We have a 21 up here. It might be a little bit difficult to read because it's a little dark. We have a 21 in the upper left-hand corner. Down here this says 44.96. And again, this is a square exactly off of the periodic table that you're given for the end of course exam. We want to know how many protons scandium has. For that, we look at the atomic number. The atomic number is 21. That tells us there are 21 protons. We look down here to our mass. The mass of this, rounded to a whole number, is 45. This is the total number of particles in the nucleus. Scandium has 45 total particles in its nucleus. We want to know the number of neutrons. We don't want to know the total number. So to find it, we'll take this mass, 45, minus the atomic number, which is 21. 45 minus 21 is 24 neutrons. Finally, the electrons. To find the number of electrons in our atom, again, we look at the atomic number. The atomic number of scandium is 21. It has 21 protons. For our atom to be neutral, it must also have 21 electrons. And 21 positive charges, 21 negative charges will cancel each other out. The total charge will be 0. One more example, chlorine, another very common element that we deal with. 17 is this number on top. On the bottom we have 35.45. This is one of those elements that we use so many times that you'll come to memorize that before too long. The 17, the atomic number, tells us that we have 17 protons. 35.45 rounds to 35. That is the total number of particles in the nucleus. We want to know neutrons. So again, neutrons will equal the atomic mass minus the atomic number, 35 minus 17. We do our math. 35 minus 17. We find that we have 18 neutrons. And yes, I went for a calculator there because I don't want to make a mistake. And you can do the same on my test, you can do the same on the quizzes, you can do the same on the end of course exam. For our electrons, again, we're going to be the same as the protons because this is assumed to be a neutral atom. 17 positive charges would require 17 negative charges to cancel it out. Now, in all the examples that I gave you, we had a different number for the number of neutrons. There are many on the periodic table that you'll find that all these numbers will be exactly the same. That does happen. Hydrogen often throws students off when they calculate the number of neutrons. For hydrogen, it's 0. And it is for the average atom, because there's no repulsion in the nucleus. There's only one proton there. Neutron's job is to overcome repulsion. With only one proton, there's no repulsion to overcome. If you have any questions, make sure you post them on the wall or ask me sometime during class.